Hi, welcome back. If you're watching this video, it means that you're now ready to dive in to solving real-world application problems having to do with logs or exponentials. Now, if you're like most people, solving word problems can be a little bit intimidating. So the purpose of this video is not to go through actual examples, but to introduce you more to the process of solving these word problems so that then we can go do some examples. So again, if you're an individual that really struggles with word problems or they intimidate you, I highly encourage you to watch this video first so you can have an overall idea of the strategy that you should use, and then the next video will go through some specific examples. Okay, so with a lot of applications for math, I'm a big fan of analogies. I think analogies are a great way to learn. And so I'm going to use a sports analogy here. So just like I have my favorite football team, they play on Sundays during NFL season. They don't walk onto the field on game day just hoping for the best, hoping they're going to play well and have a great game. They practice, they plan, they strategize, they organize. So that's what you've been doing over these last couple of lessons. You've been learning and strategizing and organizing in your brain how you manipulate and work with logs and exponentials. You've learned the log rules, the exponential rules, how to solve equations, how to manipulate equations, and probably even learned how to graph those two types of functions. So this was all of your preparation, so now you're ready for game day. So game day's arrived and you are now going to be expected to actually solve real problems involving logs and exponentials. It's actually pretty exciting. There's some cool stuff you can do. But before we talk about the specific process for logs and exponentials, let's just take a step back and talk about solving word problems of any type. So it's a process, what I like to call a four-step process. So I have it captured here on the board. So number one, when you're solving a word problem, you're not going to solve it right away. So don't even think that you can. I encourage students not even to write anything down the first time. So when you read it the first time, you're just literally reading it and trying to understand, what are they talking about? Are they talking about money? Are they talking about population? Are they talking about the wind speed of a tornado? Like, what are they even talking about? And if you can figure that out, it kind of just puts your mind in the right mindset, the right frame of mind, so you can almost imagine and envision kind of what's going on here. And that just allows you to get a little bit more immersed in the problem, and then maybe it seems a little less intimidating because it seems more like real life. So read the problem, just what are they even talking about here? Then you're going to read the problem a second time. The second time you read it, you're actually looking for, what are they asking you to find? Are they asking you to find an interest rate? Are they asking you to find the speed of their tornado? Are they asking you to find how long you want to let money sit in an account? So there's something they want you to find. A lot of times that's written at the end of the word problem in the very last sentence, but not always. So you need to seek out, what are you trying to find? And then once you have figured out these two things, you know what's the topic and what am I trying to find, you'll be able to move to step 3, which is, what equation am I supposed to be using? So in a lot of mathematical applications, there are standard equations that we use, and that's the case also for logs and exponentials. There's a portfolio of standard equations, and once you understand what you're trying to find, you can go pull the correct equation. When you do that, you're then going to be able to identify in that equation, what's the variable that represents what I'm trying to find. Is it t for time, for example? And then all the other variables that are in that equation, it means they gave you that data, they gave you that information. And so it's simple. Write down the equation, identify the variable you're hunting for, and then plug in all the other information, and then you're going to be able to manipulate that equation to isolate and solve for the variable, which is why we've been practicing all those skills. So again, it's a process, and the better you become at following this process, the more efficient you're going to get at solving word problems, and you'll get the right answer the first time instead of having to rework that thing over and over again. Okay, so now let's apply this to logs and exponentials. In a college algebra course, most of the exponential and logarithmic word problems that you're going to be asked to solve are one of 4 types. Now, you could have an occasional variation of another type thrown in there, but these are the 4 most common. Number 1 is it's a money problem. Number 2, it's an exponential growth or decay problem. And number 3 and 4, I've kind of coupled those together, are logistics or logarithmic models. And so in a diverse college algebra class, you will typically get exposed to all 4 of these. The thing to remember is for money problems and for exponential growth or decay problems, there's a canned formula. Like there is a specific formula you're going to use. If you have an instructor that doesn't provide that formula for you, you're going to have to memorize those. Logistics and logarithmic models, however, a lot of times for those, there's a very unique formula for each problem. So almost universally, if you have a logistics or logarithmic growth, they are going to provide you the actual formula as a part of the problem. Okay, so what types of formulas do we have here? Money problems. There are two different formulas for money problems, and the sooner you realize which one you are supposed to be using, you'll be off to a good start. It all has to do with how they tell you the money is compounding. So you may be given a money problem that says, I have so much money, I'm going to invest it into an account. How much money is going to be sitting there in 10 years type of thing. Well, the key that you want to hone in on, they'll tell you how the money is compounding. If it's compounding continuously, if they use that word, that's this top formula. A equals PE to the RT. Some people call it APERT for short. But if it's continuously compounding, this is your guy. Sometimes it's not compounding continuously. They tell you it's compounding monthly or compounding quarterly, compounding daily. If they use a different word, then it's this formula. A equals P times 1 plus R over N all to the NT. So these are really the only two formulas you're going to be using, and the key is to figure out which one is it. And like I said, I'll have another video where I actually do an example of using these formulas. If it's an exponential growth or decay, those all follow the same format, again, of an equation. I have two examples written here. And notice, don't get so hung up in what letters I'm using. Just notice that the exponential growth or decay, they actually follow the same format as the APERT. So this top one, for example, I have n equals n naught e to the kt. These variables all represent something, just like they did up in the money problem. This n naught, that represents the amount that you have at the beginning when time equals 0. Maybe it's the population at the beginning. The n, that equals the population, let's say, if that's what I'm talking about, after t time has gone by. And this k right here, that represents a growth or decay rate. And again, we'll do some specific examples in the next video. The key is to recognize, again, growth and decay, they follow this same type of pattern. And they may use n's, they may use m's, they may use f's. You know, don't get hung up in what letter they're using. Just make sure you understand each position, what it represents. When you have a growth formula, it's because this growth factor is a positive number. And if you remember from graphing those, when you have exponential growth, you end up with this curve that increases over time. If it's a decay function, however, you'll have this negative sign here. You can either think about the growth factor being a positive number with a negative sign then shoved in front, or you can just think about the growth factor itself being negative. But when you have a negative power up here, that's what causes the decay. And again, if you remember from graphing, you'll see a decay as you progress through time. So growth and decay. The third and fourth type, logistics and logarithmic, those are pretty neat. You can study some really amazing things. You can talk about earthquakes, you can talk about tornadoes, you can talk about sales forecasts, like how long do we think it's going to take until the newest iPhone saturates the market. Like all those types of studies, they use logistics or logarithmic growth models. There are many, many types, and that's why when you have this type of a problem, they give you the actual formula to use. And I've just written an example of one here, like r equals the log of I over I naught. This is something they use to talk about earthquakes. Actually, it's a common model. So overall, in this course, you are going to be expected to solve these types of real-world problems. Most, if not all, of your problems should probably be in one of these four categories. And the sooner you are familiar with the money formulas, the growth decay formulas, you'll be off to a good start. Again, because these formulas down here, they usually give those to you. But don't forget the process that you want to use as you jump and dive in. And so I hope that was helpful. Hopefully it gives you a little bit of an overview of how to solve these word problems. And then in the next video, we'll actually do some applications. We'll actually do some very specific examples of each of these types. And I hope that this was helpful.